So we are going to see the growth of current in LR circuit. For that, let us consider LR circuit, resistor and inductor, they are connected in series and alternating EMF is there. Now, when the tapping key is tapped or it is closed, then current will flow through the circuit. And as resistor and inductor are connected in series, therefore total voltage of the circuit is the sum of the voltages of resistor as well as inductor. That's why total voltage in the circuit is your sum of voltage. In the resistor the voltage is what? IR, and voltage in the inductor is L times di dt. Already we have discussed about it. That's known to us. Now you see, you have to consider a situation when current reaches its peak value in the circuit, that is your I naught. In that case, what happens? Inductor, there will be no opposition of current in the inductor. The property of inductor is what? It opposes the change in current. And resistor opposes the flow of current. These two resistances are different. That is your inductive reactance. What's the property? It opposes the change in current. So I mean to say, when it reaches its peak value I naught, for the time being it becomes constant. So at that moment there will be no opposition in the inductor. You can consider the inductor as a conductor. In that case, total voltage of the circuit exactly equal to the voltage of the resistor. This is the case when I is equal to I naught. In that case, RE will be exactly equal to I naught times R. That is, you can imagine this way, only resistor, you remove the inductor from here. It is like this. It is like this. So here it is the resistor and maximum current I naught we are considering. So here it will be I naught R. So total voltage directly equal to voltage of the resistor. In that case, what happens? Now you just put the value in 1. So 1 implies I naught R equals to I times R. In the right hand side it is as it is, L times di dt. Now I naught, you see, minus I, we can write R common. If you transpose it in left hand side, it will be equals to L times di dt. Implies we are going to apply integration here. That's why we are now doing variable separable. Yes, you can imagine. So here R by L dt in this side, di keep here, and this term in right side, it will be 1 by I naught minus I di. Now apply integration. Or if you integrate it, what you will get, you see. R by L is constant, take out. Integration of dt is what? T. So here only t equals to. And what is the integration of this? As you know, integration of, say, integration of 1 by 2 minus x dx. It is nothing but minus log of 2 minus x. This minus why it comes? Because x is negative here. So for the time being, you apply this process here. Then here, integration of 1 by I naught minus I minus log of I naught minus I plus c. Now you are to find out the value of c. That is constant of integration. What you have used here, value of c you are to find out. And remember, value of c always to be calculated from the initial state or initial condition of the circuit. Means when t equals to 0. In that case, current is what? Current is 0. T equals to 0 means the tapping key is in release position. When it was in this position, circuit was not closed. In that is the initial condition of the circuit. So at t equal to 0, I is equals to 0. Put the values here. You will get t 0 to 0 and I 0 minus log of I naught plus c. So easily you could calculate c equals to log of I naught. Now from here you will get, say this is your 2. So 2 implies R by LT equals to minus log of I naught minus I and plus log of I naught. This we have got. See, now let me rub this part here. Rest of the part I am showing here. From here you will get minus R. Do one thing. All this term take in the left hand side. Log of I naught minus I minus log of I naught. If I write this in the right hand side, left hand side, and this in right hand side, you will get equals to minus R by L times T. Now it's a property of log you can use, because log A minus log B is what? Log A by B. So you can write log of I naught minus I by I naught equal to minus R by L times T. Then you can take ND log. Here base is your always E, because it is natural or Napier's logarithm. From here you will get I naught minus I by I naught equal to e to the power minus R by L times T. Okay, clear? So almost you have done. Here term wise you divide by I naught. I naught by I naught is what? 1 minus I over I naught equals to e to the power minus R by L times T. Okay, now let me write here next part. See, from here you can find out the value of I. So value of I will be implies minus I by I naught. So 1 minus, take it in left hand side, e to the power minus R by L times T. I have transposed this in the left hand side and this is in the right hand side, equals to I over I naught. Now easily you can see I will be your I naught times this much. Okay, so from here what you will get, I is equals to I naught times 1 minus e to the power minus R by L times T. It is 1 minus e to the power minus R over L times T. So almost we have got the expression for I. So here we can show it. Finally, you have got I is equals to I naught into 1 minus e to the power minus R by L times T. This gives you 1 minus e to the power minus R by L times T. This gives you the instantaneous current. When you close the circuit, means current is growing in the circuit. Switch on, in that case current is gradually growing. So during that time, at any moment, what is the value of current? Say whenever you plug in the switch, then after 5 seconds, at t equals to 5 seconds, what is the current? Instantaneous current. So that value you can calculate from here. One more thing you remember, this can be written as I equals to I naught into 1 minus this minus r by L times t, we can write it. It is actually e to the power minus r by L times t. So you can write it t divided by or minus t. This r by L we can write L by r here. Let me write in a clear way. I mean to say I is equals to I naught 1 minus e to the power. This term can be written as small t by minus L over r. Check it. Simple. Just it's reciprocal. I have written in the denominator, and it will be again minus r bar by L into t or RT by L. This minus L by R, this term, this L by R, L is the inductance, R is the resistance. And if you check it, dimensional formula, if you find out, or simply units of inductance and units of resistance, if you take the ratio or dimension of L by R, if you find, you will get the dimension of time. Means this ratio L by R represents time only. What physical quantity? Time. And this is called your time constant. This L by R is called time constant, denoted by tau. The final expression in your textbook, you will get I is equals to I naught times 1 minus e to the power t or minus t by tau. What is tau? Now you can say where tau is equals to L by R is called time constant. In next class, I will justify it, how it's time constant. Just you will find at home, you can also do it. Just find out the dimension and you will see it's a time only. And then there are some particular cases from here we are going to check. In next class we will continue it. Thank you.